Hi everyone, my name's Erica and I am recording the second video associated with the lesson on ocean acidification. This is the follow-up to the lesson presented earlier by Vanessa. Quickly about me, I'm a fourth-year PhD student at Scripps Institution of Oceanography and have been very privileged to grow up near water and always having been very interested in the ocean. And often when I present these lessons in person, I like to include this picture in the middle, which shows me and several other friends and colleagues at the United Nations Climate Conference. This conference is held annually, and what I really love about my time from the last conference is that I was just so inspired to see how big of a difference that kids not much older than yourselves made and what sort of influence they had on the negotiations. So you're kind of never too young to start talking about climate change and advocating for issues related to climate action. As you saw in the cabbage experiment, CO2 from your breath reacts with water to affect the pH of the solution. And we know that oceans are getting more acidic as CO2 accumulates in the atmosphere, and some of that CO2 is sequestered in the ocean. So using various instruments, scientists have learned beginning in about the late 1980s that the pH in the ocean is actually declining. So just to orient you to this graph, you have time on the x-axis and the concentration of carbon dioxide in the atmosphere, or in this case in water, on the left vertical axis. On the right vertical axis, you have pH, and you can see that as atmospheric CO2 levels have risen, so has the amount of CO2 sequestered in the ocean in dark blue, and gradually the pH of the ocean has started to decline, shown in light blue. It's anticipated that pH may fall another 0.3 to 0.4 units by the end of the century if we don't do everything in our power to abate emissions released into the atmosphere. And just to bring home the point about how important this number is, remember that pH is not listed on a linear scale. So the difference between 0.3 and 0.4 pH units is actually quite high. Why does this matter? Many of you may already be convinced at this point that ocean acidification is an issue to be aware of, and that we should be doing everything in our power to stop ocean acidification. But for those of you who are not convinced, we can think a little bit about the chemistry in the ocean, how this ocean chemistry has impacts on flora and fauna that are both important to us culturally, but also important to us as a source of food. So free hydrogen ions react with carbonate ions in water, which are the building blocks for animals with exoskeletons such as corals and shellfish. Without these carbonate ions, small corals and shellfish can't create their exoskeletons to grow bigger. And over time, more acidic seawater can actually erode away at these exoskeletons, making them weaker and easier to break. And if, for example, you're a seafood lover and you like to eat shellfish, issues such as ocean acidification combined with warming and so on can have serious consequences on the fisheries that we are interested in and utilize in our daily lives. But if you're not much of a seafood eater and you just love the marine environment and you love the beauty of the ocean, ocean acidification is also a serious issue to be aware of. Indeed, ocean acidification is already affecting tiny creatures that live along the west coast of the United States, known as pteropods. So these organisms are quite common and form the base of the food chain. In fact, they're so common that I had one advisor who referred to them as the potato chips of the sea. They're these cute little snails that float around in the water column. They're sometimes called sea butterflies, and without them, it's quite possible that animals further up the food chain may go hungry. And this really brings home the idea that everything in the ocean is connected, if not through direct interactions, then through the rather complex food webs that are made up by first the plankton, the organisms that eat the plankton, the organisms that eat the organisms eating the plankton, and then eventually you'll make your way all the way up to the food chain to, for example, us. So without pteropods and clams to eat, larger ocean animals may have left to eat, could starve, and potentially die. But we also know that there are non-lethal effects of ocean acidification to organisms. So it's conceivable that ocean acidification might lead organisms to perish, but it's also just as conceivable that ocean acidification will lead organisms to basically lead less healthier lives. And what scientists have learned recently is that ocean acidification actually has effects on some species of sharks that have dermodenticles. So if we just break down this word dermodenticle, dermo means skin, and denticle, think denticles like dentists, think teeth. And so it turns out that sharks and other elasmobranchs, that is sharks and rays, have these kind of tooth-like structures that cover their skin. And typically, these dermodenticles help them glide quickly through the water, protect against bites and parasites. But long-term exposure to ocean acidification may erode away at these dermodenticles, perhaps making them more vulnerable to these things that I've just listed. So what are some of the things that you can do to help stop ocean acidification or to help stop ocean warming, as you learned last week? The first and one that's quite popular to talk about is modifying your own personal diet. So try to eat more fruits and veggies, eat less meat. We know that meat, on average, takes many more emissions per kilogram of product than, for example, vegetarian products, fruits, veggies, etc. Conserve energy, walk, bike whenever you can, and turn off electrical power strips and light switches when you see them and when that source of electricity is not in use. And one that I think is really important and sometimes undervalued is just to continue to educate yourself about these issues, learn more about global warming, but also practice your own interpersonal communication skills. So this brings us to the next slide, where we want you all to know that one of the most important things you can do is to simply talk about climate change. In recent polling of folks who live in the United States, it turns out that most people actually do believe that climate change is an issue, but most people don't talk about it. And so you can plan climate action activities with your classmates, teachers, friends, family, and really spread the messages and spread the lessons that you've learned here. It's also important to note that you as kids are excellent messengers. People love to listen to you. People want to know what you have to say, and you're very influential. And so if climate change is an issue that's important to you, it's more likely to be important to the people around you. Your voice matters. There are kids all around the world organizing around issues of climate action, from Sydney, Australia, to Seoul, South Korea, to here in San Diego. So this picture was actually taken at the Climate March in San Diego a few years ago. And it's just been really inspiring to me to see how important kids' voices has been in the conversation around climate justice and what we're going to do to solve these rather tremendous challenges that we are facing in our lifetimes. So I know it's a virtual recording and there's no way to ask questions directly in this interface, but if you have any questions, please feel free to ask me or Vanessa or any of the Stay Cool leaders that you have access to. We're always happy to answer questions about the science, but also questions about the actions you can take to help be a part of the solution and the best path forward. So thanks so much for listening and have a good one.